Welcome to 15.4, Adding and Subtracting Radical Expressions. So when it comes to adding and subtracting radical expression, it's going to be very alike to combine like terms. So for example, in the previous parts that we have and previous classes that you have seen, here we're just going to combine. So 5x plus 3x will equal to 8x because it's going to be like terms. They both have x, so you can combine them. Same thing as saying $5 plus $3 is equal to $8. So when it comes to radical expressions, which I'm going to do in an example, but using these numbers. So say instead of 5x, I have 5 square root of 2 plus 3 square root of 2. So since both of these terms, they both have square root of 2, that means that we can combine like terms. So again, I'm underlining my like terms, meaning that the 5 and the 3 have square root of 2. So it's going to be very much the same process as the previous example. So my answer would be 8 square root of 2. And again, just like terms. So just like saying $5 plus $3 is $8. So in this case, 5 square root of 2 plus 3 square root of 2 is equal to 8 square root of 2, where I just add the coefficient, the numbers that's outside the radical, since, and I emphasize this, since the radicals which are exactly the same, we can combine like terms. So this all is basically combine like terms. Now, if a problem does not have like radicals at the very beginning, then you have to double check if you can simplify, which you will see with the following examples. In this example, we have 4 square root of 3 plus the square root of 48. Now, let's take a look at the first radical expression. Inside the radical is a 3, meaning that you can't do the square root of 3, nor you can simplify any further, so this one is done. It's simplified. Let's take a look at the second radical expression, the square root of 48. You can actually simplify this because when you break it down, one of the factors can be a perfect square number. In this case, when you break it down, it's going to be the square root of 16 times the square root of 3. Because 16 times 3 will equal to 48. And then I'm going to bring down the 4 square root of 3 with the plus. Now the only one that you can simplify is the 16. So the square root of 16 is 4. Can't simplify the square root of 3, nor can't do it, so I'm just going to bring it down and put it next to the 4, so it's going to be square root of 4. And then I bring this one down, the whole thing. So it's going to be 4 square root of 3 plus. Now, since both of them have square root of 3, that means that I can add the outside number. So 4 plus 4 is 8, and then square root of 3. So that's going to be my final answer. And box that up. Now to review with this example, the first radical expression was in its simplest form, whereas the second one was not, the square root of 48. So what I did was I broke down 48 into two factors, 16 and 3, where 16 is the perfect square. Hence, I was able to do the square root of 16, which became 4, and then I brought down the square root of 3 because I can't simplify nor do the square root of it. Afterwards, I noticed that both of my radical expressions have square root of 3, so that means that I can add the outside number, 4 plus 4, which is 8, then carry the square root of 3, hence this is my final answer. In this example, we have the square root of 125 minus the square root of 20. So, closely examine these two radical expressions. I know that they are not in simplest form because we can break up 125 where one factor would be at 25, that's a perfect square number. Whereas we can break up the square root of 20 into two factors where one can be 4, which is also another perfect square number. So let's do that. So the first one, I'm going to break up square root of 125 into the square root of 25 times the square root of 5, because 25 times 5 will equal to 125. Next, I'm going to break up the square root of 20 into square root of 4 times the square root of 5, because 4 times 5 is equal to 20. Alright, so let's take a look at the first radical expression. Now the only one that I can do the square root of is the 25. So the square root of 25 is just 5. I can't simplify nor do the square root of 5, so I'll bring it down and put it next to the 5. So when I simplify square root of 125, it will become 5 square root of 5. Bring my minus, and then last. Now the only one here I can only do the square root of is the 4. So the square root of 4 is 2. Cannot simplify nor do the square root of it, so I'll bring it down, and I'm going to have 2 square root of 5. So from there, I notice that both of my radical expressions that I have now, they both have square root of 5, so that means that I can combine them like terms. So I'm going to do 5 minus 2, which is 3, and then carry my square root of 5 into my final answer. So my final answer is 3 square root of 5. So in this example, we are subtracting the radical expression, but at the beginning we had both radical expressions that were not in its simplest form. So we just break it down into two factors where one of them is a perfect square number, and then continue simplifying. Once I finish simplifying, I just combine like terms because both of them have the square root of 5. In this example, we have another one where we are subtracting radical expression. So let's take a look. We have the square root of 18 minus the square root of 72. Now, they're not in the simplest form because for 18, 9 can go in 18, which is a perfect square number, whereas for 72, 36 can go into it, where 36 is also a perfect square. So we're going to simplify. So the first one, I'm going to break up square root of 18 into square root of 9 times the square root of 2 minus, and then for the square root of 72, I'm going to break it up into square root of 36 times square root of 2. Alright, so let's simplify the first radical expression. The square root of 9 will be 3. Now, the square root of 2 can't simplify nor do the square root, so I'm going to bring it down and put it next to the 3. Now for the second part, I can do the square root of 36, which is basically 6. I cannot do the square root of 2 nor simplify, so I'll bring it down and put it next to the 6, like so. Now from there, I notice that both of my radical expression have square root of 2, so I'm going to combine the outside number. So 3 minus 6, that's negative 3. And then I'm going to carry my square root of 2. So this is my final answer. So in this example, we had to simplify both radical expression that we had in the beginning, and then when we simplify, we had 3 square root of 2 minus 6 square root of 2, whereas I combined the outside number, 3 minus 6, which came out as negative 3, and then carried the square root of 2.